Hey class, so some of you have asked about this problem 11 on the homework, which is a little bit of a tricky one, so I thought I'd make a video to help you guys kind of get started on this. So we're told here we have a LC circuit that has a variable capacitor. So we have a variable capacitor that ranges from 10 picofarads to 293 picofarads in this case. And so yeah, we're first asked to figure out what is the maximum the ratio of the maximum frequency to the minimum frequency that can be obtained by this capacitor. And then after that, we're said, okay, imagine that we have a desired range of frequencies from 0.69 megahertz to 1.2 megahertz. What you'd find, or what you're going to find as you go to solve this, is that the capacitance you currently have is not sufficient to give you that range because you end up with too high of a ratio from part A. So what you have to do then is put a additional capacitor in parallel with your variable capacitor in order to achieve this desired range. And so part B asks you what is that capacitance, and then part C asks you what is the inductance of the inductor coil. So let's go ahead and look at this. So all of this problem, as you can see, is focused around the frequency of your LC circuit. So if you remember from class, I gave you guys that omega, the angular frequency of an LC circuit, is equal to 1 over the square root of L times C, the inductance times the capacitance. And if you remember from all the other things that we've done in class, dating back to the very first chapter, we know that omega is equal to, that equals is and omega, both a little ugly, so let's redraw those. Okay, so omega is equal to 2 pi multiplied by f, the frequency. So frequency in this case is going to be equal to 1 over 2 pi times the square root of LC. So if we wanted to find the ratio of our frequency, minimum to maximum frequency, or excuse me, maximum to minimum frequency, what we're being asked to find is this ratio, which maybe I'll call the ratio capital R. We're being asked to find the ratio of the maximum, F max, over F min. All right, so just so we're aware, when is our frequency going to be at its max? Well, since it depends on 1 over this variable capacitor, it's going to be at the maximum when you have the smallest capacitance, and it'll be at a minimum when you have the largest capacitance. So you could rewrite this as being equal to R is 1 over 2 pi times the square root of L over C min divided by 1 over 2 pi times the square root of L times C max. So we can do some reducing. We can get rid of the 2 pi's, the L's will end up canceling, and since you got the 1 over square root C max on bottom, 1 over square root C min on top, this actually reduces much more simply to the ratio is just going to be equal to the square root of the maximum capacitance over the square root of the minimum capacitance. So that's nice and easy. So for part A, you just do this calculation and you get some number. Cool, easy enough. So that's part A. Boy howdy, all right. So then part B now, we're told that we want this new range to give us which gives us a different ratio than what we found here in part A. And in order to achieve that, there must be a capacitor in parallel. So let's scroll up here in order to see what we can do for part B. All right, so for part B now, just to remind you, we have capacitors in parallel, so our new capacitance, our new maximum capacitance, for example, is going to be equal to C max from before plus this additional capacitor in parallel, because in parallel you just add the capacitance, and C min is just going to be equal to the previous C min, maybe I should do C max initial and C min initial, plus this additional capacitor, maybe I'll call it CA for additional capacitor that we're adding in here. So now what we can do is we're going to have a new ratio of our desired frequencies, and it's going to be equal to, once again, the square root of C max over square root of C min. So it actually is quite simple. The ratio, which is going to be equal to the frequency max given in the problem statement over the frequency min given in the problem statement, is just going to be equal to the square root of C max over the square root of C min, where C max and C min are just these two equations here. So you're going to have, well, maybe I'll rewrite this. Okay, so I can assume you guys will be able to calculate the ratio just from the two values given in the problem statement, and that's going to be equal to then the square root of C max initial plus this constant CA that we're trying to find over the square root of C min initial plus this CA. So you have CA on the top and bottom. You have to do a little bit of algebra, but you should be able to solve and figure out what that CA value is equal to. So when you finish solving, you should get some number. All right, boy howdy, boom, box worthy, green box of joy. And then lastly, in part C, you're asked to figure out what the inductance is of this circuit. So for that one, it should be pretty straightforward because you know, as we have used already, frequency is equal to 1 divided by 2 pi times the square root of L times C. So you choose one of the frequencies and you choose the capacitance that gives you that frequency, either the max or min frequency and either the min or max capacitance, now using CA, right? So again, this is going to be equal to C initial, whichever your C initial is, plus CA, all right? But you just solve for the inductance. So I'm not going to give you any more on that, but I bet you guys can solve. So let me know if you have any questions, and I hope you guys are having a great Thanksgiving weekend.